Hi, I'm going to talk to you about carbohydrates. For those of you who have the book, this is Module 1.2. We'll go over some information on carbs, and then I'll give you a chance to discuss some of those claims you may have heard about carbohydrates, such as carbohydrates are addictive, sugar causes hyperactivity. I want to know, where did you get that information from? What have you heard about it? And then we'll talk about those claims. Okay? All right. So let's have a look. Carbohydrates, or carbs, are made up of carbon, hydrogen, and oxygen. And henceforth I will write them, if you see me writing them or in any of these presentations, carbohydrates will be CHO. And that carbon is what makes them organic from a science perspective. It's a compound because it has more than one element in its structure. Carbohydrates are formed through the process of photosynthesis, where you have carbon dioxide and water on the left coming together with energy from the sun and chlorophyll in the plant to produce a molecule of glucose, and 6 molecules of oxygen are released. This is not what's called a balanced equation, so please don't check my numbers on it. Carbohydrate provides 4 calories per gram. It is the preferred energy source for the body, the brain, the central nervous system, the red blood cells, skeletal muscles. It's what the body needs for energy. The body requires carbohydrates, specifically glucose, which we'll talk about in a few minutes. It is the primary fuel that provides energy for high-intensity, short-duration exercise, which is why folks following the low-carb diets may have difficulty with their sprinting or their high-intensity exercise because their muscles need lactic acid, which comes from carbohydrate. Carbohydrates provide us with the energy currency of the cell, the ATP, at the fastest rate. We categorize carbohydrates as simple and complex, as well as refined. Simple sugars are made up of monosaccharides on the left, glucose, fructose, and galactose. No, you don't have to remember any structures. And they're also made up of the disaccharides, 2 monosaccharides linked together. 2 glucose molecules give us maltose, glucose and fructose give us sucrose, glucose and galactose give us lactose. Common names for sugars include blood sugars for glucose, fruit sugar for fructose, table sugar is sucrose, lactose is milk sugar, and we'll talk about lactose intolerance when we look at food issues and intolerances. And malt sugar, 2 maltose monosaccharides linked together, I call beer sugar because my husband makes beer and he needs his malt sugar. Complex carbohydrates include polysaccharides such as starch, which are alpha-linked glucose molecules. We'll talk about that in a second, that are linked together and can be broken apart during digestion by an enzyme, alpha amylase. You don't need to know that now, but those molecules are broken apart and release energy. That's why starch is digestible and provides calories. These glucose molecules are then released and absorbed into the bloodstream, and that's why glucose is also known as blood sugar. We also have fiber, a polysaccharide that is made up of beta-linked glucose molecules, and these beta-linked glucose molecules cannot be broken apart by enzymes in the human body. In cows, yes, humans not so much, so fiber is indigestible and non-caloric. Therefore, the glucose units that are linked together with these beta links are not released into the bloodstream. We do not absorb fiber. Cellulose is the most common type of fiber. If you've ever eaten celery and gotten those little pieces stuck in your teeth, those are cellulose fibers. So starch is a polysaccharide. That's how the plants store carbohydrate. Mammals, of which we are included, we store carbohydrate when we consume it and we're not using it immediately for energy. We store it in our muscle and our liver. We have a limited capacity to store carbohydrates, so when